This is the demonstration of the re-entry minigame in Gravity Engine 2.3. The new item in Gravity Engine 2.3 that this scene is demonstrating is the Earth atmosphere model. So as you get to within about 100 kilometers of the surface of the Earth, the air resistance drag force will be applied to the spaceship. And so if you look at the scene, what we have is we have a spaceship. I've set up an orbit so that the orbit dips down closer to the Earth so that it will start to experience air resistance. And I've set the starting phase so that we're about 280 degrees starting from here around, so that we'll start off a little bit above 100 kilometers and then descend into the atmosphere, and we'll see the effect of the atmospheric drag. So the Earth atmosphere model requires you to put in a height for the surface and some parameters that describe your spaceship, specifically how heavy it is in kilograms, the cross-sectional area in meters squared, and a dimensionless drag coefficient. It's typically between 2 and 2.3. For a sphere, it would be 2.1. And then in addition to this Earth atmosphere script that's been added, there's an Earth impact script that's been added, and that will be triggered by the Earth atmosphere when the height reaches 0. And the Earth impact script is detected by the Earth atmosphere script. It's an extension of an abstract class that it's looking for as a common component. In order to accurately do the physics of the atmospheric drag, what's necessary is for every time we do a force calculation of the force of gravity, we also need to account for the force of air resistance, and that force is velocity dependent, actually depending on the square of the velocity. And so in order to make that more general, the facility that's been added, if we just pop into Visual Studio here for a second, you can see we have this class Earth Atmosphere, and it's implementing this interface called Gravity Engine External Acceleration. So that's going to be called every integration step to compute the drag, and if we go down to look at the method that gets called, it's just called acceleration. You're given a time, a gravity state, and we can pass back the mass. That's useful in the case where we have a rocket engine burning fuel and the mass is decreasing. This same interface is used for thrust for rocket engines now. That's another change that comes along in 2.3. So the atmospheric model is trying to be fairly efficient, so it pre-computes a number of resistances at different heights in kilometers and then interpolates between them so that it's not doing things like exponential operations every time we do a force calculation. So going back to the Unity scene, we can now go ahead and press play and see what happens to our spaceship as it gets into the atmosphere. So I've taken a model from the NASA models site. That's a terrific site. None of the models themselves are copyright. You have to avoid using things like NASA logos. They're sensitive about the use of those. So I've added altitude in kilometers here, and I've also added a field demonstrating the drag. So as we get below 100 kilometers, you can see the drag is starting to increase quite significantly in meters per second. So we're now coming up to 7, 8 Gs, topping out at about 8 Gs, and now starting to decrease. And now we're in free fall at an altitude of about 21 kilometers, and you'll notice as we reach terminal velocity, the force of gravity should equal the force of drag, so we should end up around 9.8 meters per second squared. Here our altitude is going down, we're getting closer to our terminal velocity, getting quite close to 9.8 meters per second squared. And then at altitude 0, the Earth impact script hits. Because of the speed we're going, we have yet to have moved the ship right to the surface of the Earth, so that needs to be perhaps nudged a little bit in the fine-tuning here. Let's leave that. So it's not much more complicated than that. You have a spaceship, you attach to it an Earth atmosphere model, you can choose to add an Earth impact script. That impact script is the thing that stops the ship from falling through the Earth. It essentially inactivates the body and removes it from Gravity Engine. So that's a useful part of this whole setup. Hope you find this scene useful. Thanks for listening.